This is T2 Day 21, solving equations algebraically. We're going to start with problem number 1, solve 200x to the negative 2 plus 8x equals 0. We have a couple of different ways to do this. First thing I'm going to do, though, is I'm going to notice that I have x to the negative 2. So I'm going to rewrite that as 200 over x squared plus 8x equals 0. I have a couple of ways to do it here. I could simply multiply each side by x squared, and I know that I'd need to be sure to distribute that x squared to both the first term and the second term here. Or I can subtract the 8x from each side and then cross multiply. Either one of those will get us to the same place. So let's go ahead with this distributive. And I've got 200 plus 8x cubed equals 0, or 8x cubed equals negative 200, x cubed equals negative 200 over 8, which is negative 25. So x equals the cube root of negative 25. Not a particularly nice answer, but that's okay. Now we want to check it, though, and see if that answer is correct. So for our check, take our original equation, the 200 times cube root of negative 25 to the negative 2 plus 8 times the cube root of negative 25. And we want to know, does that equal 0? Well, rewriting that, I have 200 over the cube root of negative 25 squared plus 8 times the cube root of negative 25. And I still want to know, does that equal 0? Well, it's going to be easier to add these two terms together if I can get a common denominator. And it'd be easier to have a common denominator if I didn't have this radical. So we're going to go back to that Algebra 2 skill of simplifying or rationalizing a denominator. And I'm going to multiply by 1 in a form that's going to help. I'm going to multiply by the cube root of negative 25 over itself, because I've got the cube root of negative 25 squared here. If I multiply by another cube root of negative 25, I'll have the cube root of negative 25 cubed. Cube root cubed gives me just the negative 25 in the denominator. And on the top, I've got 200 cube roots of negative 25 plus, well, if I want to have the same denominator here as I have here, I'm going to want a negative 25 here. In order to get the negative 25, I'm going to need to multiply this by negative 25 over itself. So I'm going to have negative 25 times 8 times the cube root of negative 25, and I'm still asking, does that equal 0? Well, let's see. I've got 200 cube roots of negative 25 over negative 25. I could reduce that. I have plus a negative, negative, negative gives me a positive, but I'm going to keep that common denominator that I want. It's tempting to cross those out, but 8 times 25 is negative 200 cube roots of negative 25. Does that equal 0? Sure it does. I've got a positive cube root of negative 25 and a negative 200 cube root of negative 25 gives me 0 over negative 25, which does equal 0. So that check worked. Long problem. Longer check than the problem was. but I wanted to make sure that I had done it right. So I'm going to make this a little bit smaller, get it out of here for us. Okay. On to problem number 2. The first part of this problem is that we want to state the domain of this function. So if we want to talk about the domain, we're always asking ourselves, what am I allowed to plug in? The domain is the set of x values, the set of inputs, the values that I'm going to enter into my function. So what am I allowed to plug in for x? Well, this first x, the 1/2 x, that's unlimited. There's no reason why I can't put anything in for that x. But the x that shows up underneath the radical sign, remember that I can only take the square root or any even root of positive numbers. So I know that this 100 minus x squared needs to be greater than or equal to 0. Well, if I think about 100 minus x squared, I know I've got a parabola. I know when I draw that parabola, it's an upside down parabola, or parabola opening down. And I know that my intercepts are -10 and +10. So this function must be positive when x is between -10 and 10. So our domain is from -10 to 10. Find all the maximums, minimums exactly, and verify which is which. Okay, so I'm going to come back up to my original equation. If I'm looking for maximum and minimums, remember back a few weeks ago, months ago, we were looking for the derivative and where the derivative is equal to 0, because we're talking about the slope. We want the slope to be 0, and the slope of the tangent line is going to be 0 either at the top of a hill or the bottom of a valley. So I'm going to take my original function, write it back down here again so I've got it where I can work with it, equals 1/2 x, and I'm going to rewrite it in a form where I can take the derivative. So instead of that radical sign, I'm going to use the exponent of 1/2. So taking the derivative, I've got to use the product rule. I've got this as my first and this is my second. So my derivative is going to be my first times the derivative of the second. So 1/2 100 minus x squared to the -1/2. And then chain rule, I've got to multiply by the derivative of the thing that's in the parentheses, so by a -2x. And then plus the second times the derivative of the first, which is just the 1/2. So when we were just practicing derivatives, that seemed like a really silly problem to have to take the derivative of. Now we see that we've got an equation we're trying to find maximums, mins of, so there's a reason to take the derivative. There's also a reason to simplify it now, because I'm going to need to, if I'm going to find out where the max and mins are, I'm going to need to set this equal to 0 and solve for x. And in the form it's in right now, that just doesn't seem like something I want to do. So let's go ahead and simplify that. Let's look at this first part. And we've got this is multiplied by this, which is multiplied, multiplied, multiplied. I don't have any addition and subtraction from here through here. So I'm going to take this part and decide what stuff goes on the bottom and what stuff goes on the top. And is there anything that I can cancel? Well, I've got a 1/2 and another 1/2, so both of those 2's are going to be on the bottom, but this 2 is on the top. So I'm going to go ahead and I'm going to cancel that 2 with that 2. I've got to make sure I don't lose that negative. But when I write this term, I now have this 2 on the bottom. I've got that x on the top. This parentheses is raised to a negative power, so let's make that on the bottom, and we'll put it back in the radical. And I still have another x on top. So, and that negative. So negative x squared and 2 square root of 100 minus x squared on the bottom. And then for the second term, this is a positive exponent, so that radical must be on the top, 100 minus x squared, and that 2 can go on the bottom. And I need to set that equal to 0 so I can find where the max and mins are. So I have an equation that needs to be solved. Up here, we multiplied each side by the x squared, but I said we could have moved this 8x to the other side. We could have subtracted 8x from each side and then cross-multiplied. I think in this case it might be easier to do that move and then go ahead and cross-multiply with having a 0 over here. So since this term is negative, I'm going to add it to each side. That's going to allow me to not have to deal with that negative again. So I'm going to keep this term on the left. I've got my 100 minus x squared over 2 equals, adding this term to each side, positive x squared now over 2 square root of 100 minus x squared. And then cross multiplying, I have here, I have the same radical, so I've got 2 times square root of itself is going to be just that 100 minus x squared. And on the other cross, if the cross multiply, I end up with 2x squared. So using my distributive, I've got 200 minus 2x squared equals 2x squared. Adding 2x squared to each side, I have 200 equals 4x squared. Dividing by 4, x squared equals 50. So x must equal, and careful, plus or minus, square root of 50. And we could reduce that and say that's the square root of 25 times the square root of 2. So it equals plus or minus 5 root 2. In this case, I'm happy to have you leave it in either way. And we could also consider about how big is the square root of 50. It's a little over 7, so a little bit bigger than the square root of 49, so 5.1-ish. Okay, now I've got to decide where my maximums and minimums are, and I've got to verify which is which. So I'm going to come back to that sign chart I've used over and over again. And now we're talking about a prime of x. My two key values are negative square root of 50 and the positive square root of 50. And, well, I'd love to be able to just look at that equation, which is up here, and say, I'm going to stick in my a prime root of x here again, and say, oh, well, it just looks like a parabola to me. But it's not so easy. When we've had equations before, we've either been able to take our 2 or 3 factors and put along here and do our sign chart, or we've been able to say, oh, well, this just looks like a parabola that opens up, or it looks like a parabola that opens down. That's not going to be so easy with this one. We've got to think it through. Because what I'm going to start by looking at is, what if x is in one of these regions? Easiest region is this one, because I know that 0 is in this region. 0 is between negative root 50 and positive root 50. Well, if I plug in a 0 over here, my first term is 0. If I plug in a 0 here, I've got the square root of 100 over 2 is a positive value. So while I know that these are my two zeros, it's positive between here and here. If I plug in something larger than root 50, and thinking about an end value, well, we know that x has to be between negative 10 and 10, so let's look at our negative 10 and our 10 values. What happens when x is between square root of 50, and it can go up and it can equal 10, so we can even plug in 10. If I plug in 10 here, am I allowed to plug in 10? No. If I plug in 10, I've got a 0 in the denominator. Can't do that, so this must need to be parentheses and not accept that 10, but something getting really close to 10. This is going to be a negative value. This is going to be very, very small. And this is going to be a positive value. So I end up with negatives here. And I end up with negatives here. If we're doubting that, you could certainly plug in a value on your calculator and say, just how big of a number do I get here? So that tells us, that our function is decreasing, it's increasing, it's decreasing. That means that this is a minimum value and this is a maximum value. Coming over to problem 3, our last problem we need to look at today. Given this function, find all critical points exactly. Okay, so key is we're going to be looking at points, so I need both an x and a y value. So I'm going to start with taking a derivative so I can find my max and mins. I've got 2 pi x to the first plus 2 pi, the parentheses, 200 over pi minus x to the first, times the derivative of this. Well, 200 over pi is a constant, so the derivative of that is 0, but I've got to multiply by that negative 1. Tidying that up, I've got 2 pi x minus, bring that negative over, 2 pi times 200 over pi minus x. With the distributive, I've got 2 pi x minus, well, 2 pi times 200 over pi, the pi's cancel, gives me 400, and then plus 2 pi x, or 4 pi x, combining my like terms, minus 400. And since I'm trying to find maximums and minimums, I've got to set this equal to 0. And when I do, I've got 4 pi x equals 400, dividing by the 4 first because it's easy. I've got 100, and then x must equal 100 over pi. Well, is this a maximum or a minimum? Well, if I've got 100 over pi, and I'm not going to get an approximate value on my calculator because it asked me for an exact value. Depending on what the problem would be like, I might want to get an approximation, but since it asked me for exactly, I'm just going to leave it as 100 over pi. Looking at our derivative equation right here, once it was simplified, we can see that that's a linear equation, y equals mx plus b. My m is 4 pi, which is increasing, so I know that if I were to graph a prime of x, these are negative values, and these are positive values. So our a prime of x must be decreasing and then increasing for our original function, which tells me that this is a minimum value. So now I want to find the point. So if I want to find the point, this is my x value, 100 over pi. I need my y value. So coming back to my original equation, I have a equals pi x squared plus pi times 200 over pi minus x, quantity squared. And I'm going to plug in my 100 over pi. So a equals pi times 100 over pi squared plus pi times 200 over pi minus 100 over pi, plugging in for x, squared. So I have pi times 100 squared over pi squared plus pi times 200 over pi minus 100 over pi gives me 100 over pi squared. So this must be, I've got a pi times 100 over pi squared. That can reduce to my 100 squared over just a pi. And I'm going to do the same thing here, that I have 100 squared over pi squared. So that's going to give me 100 squared over pi plus 100 squared over pi gives me 2 100 squareds over pi, which I can write out as 20,000 over pi. So my value is 20,000 over pi. So I know that that is my minimum point for this function. A lot of notes.